Hey, hello physical science, this is Mr. B. We're going to wrap up chapter 16 today with our next way of how we use heat. So first, kind of one of the more common ways that we use heat is to actually heat our homes. So we're going to look at how heating systems work and how that relates to all the kind of different ideas that we've learned about in this chapter. So most heating systems are going to use convection to distribute thermal energy. Remember, convection is the movement of thermal energy through a fluid, and it's why when there's an uneven distribution, or not even uneven distribution, just when there's hot and cold air, kind of create a little loop that's going on here where the hot air rises and the cold air sinks. So that's how heating systems are going to distribute heat and thermal energy. And so a central heating system, again, this is, hopefully you've heard maybe this before, if you ever hear your parents talking about again, the heaters in their house, they heat many rooms from one central location. So it's one central location is heating the entire house. That's why it's called a central heating system. So the most commonly used energy sources for central heating systems are electrical energy, natural gas, oil, and coal. And their heating systems differ in exactly how they transfer the thermal energy to the rest of the building. So one way is by hot water heating. So as hot water heating, there's something that's known as a boiler, and it heats oil or natural gas, and it burns and heats the water. So at the boiler, heating oil or natural gas burns and heats the water. Then the circulating pump, so there's a part called the circulating pump, it carries the hot water to radiators that are in each room, and then the hot water transfers thermal energy to the radiator by conduction, because the hot water is directly touching the radiator, so the heat flows through it that way. And so again, boiler heats up the water. Water gets pumped to the rooms through the radiator. Then the water transfers the energy to the radiator by conduction. And then the hot pipes heat the room air by conduction and radiation. So again, it's directly touching some of the air, but again, it radiates away. And so then, because it just kind of travels in waves, and then the hot air will rise and it sets up convection current in each room. And then the cooled water, after that, returns to the boiler to start the process over again. And so here's kind of an example of a picture of how that might work. So within the pipes of this hot water heating system, the water circulates in a convection current. In each room, the air also moves in a convection current. So we look here, so right here, here's our first step that we started with a boiler. So in the boiler, it heats up, again, it heats the water, and so the water moves up the pipes because it's hot, and then it moves into the radiator right here, into all these pipes. And again, it's transferring its thermal energy out through conduction and radiation. And so then the hot air, in turn, comes into the room through this red line, and then the cooler air is replaced by the hot air. So again, hot air rises, causes the cool air to sink. Cool air sinks, comes back down through here. Again, now we have cool water now because it's lost all of its thermal energy, and it comes back through here, again, back through our circulating pump, and again, it starts the process all over again right here. The hot water comes up, again, it heats the radiator heats the air, the hot air rises, the cool air that was there before sinks, comes back through, and sinks to the bottom. Now we have cold water, and then it kind of just keeps moving along like that. So that is how hot water heating system works. Again, it's constant convection, then with some conduction and radiation in there of hot and cold water. So now we have what's called the steam heating system. So steam heating is very similar to hot water heating, except that steam is used instead of hot water. So in a steam heating system, we could just change this red and blue instead of water. We can just call that steam, and it basically works the exact same way. So the transfer of heat from the steam heated radiator to the room still occurs by conduction and radiation. Again, it's the exact same process. It's just steam heating is often used in older buildings or when many buildings are heated from one central location. So sometimes multiple buildings share this little device down here. It would be much larger if it's going to heat more buildings. So that's when we would use steam heating over hot water heating. Again, they're basically same exact processes go in, except we use steam instead of water. Then another type of heating system is called an electric baseboard heating. So an electric baseboard heater, so that's going to be towards the bottom of the floor. That's what your baseboard is. Uses electrical energy to heat a room. So there's a conductor that's used to convert electrical energy to thermal energy. And then the hot coil heats the air near it by conduction and radiation, and it just creates a convection and a convection current to circulate the warm air to heat the room. So this is just going to be kind of in one room, where we just kind of have a system kind of going along the bottom part. Again, it's doing the exact same thing, it's just kind of on a smaller, more confined scale. And then our last type is called forced air heating. At least I believe that's going to be our last type of heating system that we have here. Yes. So forced air heating systems, they're going to use fans to circulate warm air through the ducts to the rooms of a building. So convection will circulate air in each room. So again, convection is a big way for heating systems to work. Warm air entering the room rises towards the ceiling, and cool air returns to the furnace through floor vents on the other side of the room. So here, this might be a little bit more, again, depending on again, the system in place. This kind of is probably one of the more commonly used things in homes and things like that. So hot air enters the room through a supply vent in the floor. So here's our supply vent. So here's our hot air. It enters the room. It enters the room and it rises because hot air rises. And now the cooler air, as it becomes more dense, is going to sink. So cooler air sinks down into the return vent, travels through the duct into the furnace, and then whoop, now we start the process all over again. Now we have warm air being pushed up, and then we have a chimney that will allow some of that excess heat to escape right there. So that's forced air heating. Again, it's using fans and vents to push hot air and create a convection current that way. So those are our heating systems. Now there's going to be something kind of the opposite of that is known as a heat pump, and it is a device that reverses the normal flow of thermal energy. So it makes things work backwards. Again, we usually go from hot to cold, and now a heat pump is going to do the opposite. It's going to make energy go from cold to hot objects. So they do work on a refrigerant in order to reverse the normal flow of thermal energy. So one of the big examples of a heat pump is going to actually be a refrigerator. And a refrigerant is a fluid that vaporizes and condenses inside the tubing of a heat pump. So inside a heat pump there's a material known as a refrigerant, and that's hopefully you can know where the term refrigerator comes from. So when the refrigerant absorbs heat, it vaporizes or it turns into a gas, and when it gives off heat, it condenses or turns back into a liquid. And so now we're going to take a look at how that works in a refrigerator, because it is a heat pump and it transfers thermal energy from the cold food compartment to the warm room. So yeah, think about it. Again, your refrigerator is always cold on the inside. That's because it is constantly moving thermal energy out. It's keeping thermal energy out to maintain the cooler inside temperature. But you got to think that thermal energy has to go somewhere. It usually goes out into the warmer room, so it is doing work to move. Again, it's colder on the inside, but still wants to remove its heat and wants to remove the heat that it has and get out as much of it as possible to the warmer surrounding area. So and the reason why that's allowed to happen is because there's a motor that does work to move refrigerant through tubing inside the refrigerator walls, and the coils of tubing underneath or behind the refrigerator, they release the heat absorbed from the food compartment and thermal energy produced by the work that the motor does. So refrigerators really have to work overtime to kind of keep themselves cool on the inside, because they're fighting against a lot of natural processes here. And so when a refrigerator door is open, some thermal energy from the room is going to enter the refrigerator. So again, if you leave it open for a longer period of time, that refrigerator is going to have to do more work to kind of balance out where it's supposed to be. And then more thermal energy leaves the refrigerator through the coils as a result, because again, it has to do more work to keep that temperature where it's supposed to be. So that's how a refrigerator works. Again, it is moving heat in the opposite direction it's supposed to do. It's moving it from the colder environment to the hotter environment. So that's one example of a heat pump. Another example of a heat pump is an air conditioner. So the compressor in a room air conditioner raises the temperature and pressure of the refrigerant, turning it into a hot, high-pressure gas. The condenser coil is hotter than the outside air, so heat is going to flow spontaneously to the outside air, and the refrigerant cools and condenses into a liquid. And you're going to take a look more about how air conditioners work in class, so again, you don't maybe need to worry about jotting all this down yet, because again, you're going to take a more in-depth look at it. And The liquid refrigerant then flows through the expansion valve and decreases in temperature. Again, there's a picture of this in your book that you're going to have to look at that's going to make a little bit more sense than this. So as the cold refrigerant flows through the evaporator coil, it absorbs thermal energy from the warm room air, and the fan sends the cold air back into the room. Then the refrigerant becomes a vapor, and the process starts all over again. And like I said, we're going to worry about air conditioners more in class, so don't worry about writing any of this down because you're going to have to do it again more. We'd rather just have to do this in class where it's a little more concrete, a little better picture, so we can kind of make more sense of it. So that's it for this section. Let me know if you have any questions.